No. All right, lesson 24 is more practice with solving equations using the unit circle. So last time I told you that this is the most important concept, I feel like, in pre-calc to prepare you for calc. Okay, so when anybody says, what should I make sure that they know in pre-calc to help them with AP Calc, I say this. So solving equations using the unit circle. All right, so we've already done this. We're going to do it again today. And then you'll have maybe 20 minutes to work on your homework at the end, okay? So, number one, so we have sine of x equals negative root 2 over 2. So remember, what we're doing is we're thinking about the unit circle, and we're saying when is the y value on our unit circle equal to negative root 2 over 2? So that's in two different locations. So I told you to give your answers between 0 and 2 pi. So it's going to be x equals 5 pi over 4 and 7 pi over 4. Those are the two answers. Did you all know how to do that? All right, feeling good so far. All right, number 2 is probably the most missed question in AP Calc when people think back to these problems. They always forget that you cannot divide by cosine on both sides. Do you guys remember why we said we couldn't divide by cosine? If we had something like x squared equals x and we divide by x,
you lose the answer.
Yeah, you only get x equals 1. You don't get the answer of x equals 0 as well. It actually has two answers. So same thing with trig equations. You cannot just divide by cosine of x. So we're going to subtract the cosine of x over. So we have cosine of x, and then times cosine of x minus 1 equals 0. So we get cosine of x equals 0, and we get cosine of x minus 1 is equal to 0. So in other words, cosine of x equals 1. So on our unit circle, cosine is equal to 0 in two locations, right? That's the x value on your unit circle, the x coordinate. So it would be at the top and the bottom of our unit circle. And then cosine is equal to 1 in one location. Okay, you could write 0 and 2 pi for that one, but notice our domain here was 0 to 2 pi like that. 0 with a bracket, 2 pi with a parenthesis. So what one answer would I write then? Yeah, Catherine? Exactly, 0. 0 is included, but 2 pi is not. So I'm going to have x equals pi over 2, and I'm going to have 3 pi over 2. And then I'm going to have 0. Okay, if you included the 2 pi, I don't count it wrong on the test. I just kind of put a little x through it, but don't count you off any points.
What can you say again?
I don't count you off on the test if you put 2 pi as well. Like a lot of people put 0 and 2 pi for that answer.
Oh.
All right, so same idea on number 3. So we have 2 sine of x cosine of x equals sine of x. So you cannot just divide the sine of x out. So you have to get everything on one side. And then pull out the GCF, the sine of x. So we get 2 cosine of x minus 1 equals 0. So when I set each piece equal to 0, I get sine of x is equal to 0. And when I have 2 cosine of x equals, or minus 1 equals 0, I add the 1, divide by 2. So I get cosine of x equals 1/2. So on our unit circle, if we're talking about where sine is equal to 0, sine, the y value is equal to 0 in two locations. So we would say our answers are 0 and pi, and then cosine is equal to 1/2 in two locations. So can you guys think about where those would be too? So, pi over 3 and 5 pi over 3. Good. Are you guys getting to the point where you don't need to look at your unit circle? That's the goal. Uh-oh, you better put those away. All right, so this next one. Yes.
Are we going to have a unit circle for our test?
Are you going to have a unit circle for the test? Maybe you'll have a unit circle on your test that can help you.
Okay, well, I mean,
Like your study guide, yeah.
well, you're letting me.
So cosine squared equals sine squared. Your whole goal is to not have to like look at the unit circle, to be able to know where these are, right? Without, that's why we're drawing a little mini one for each one. All right, so I have cosine squared equals sine squared. So what does this mean? If cosine squared is equal to sine squared, what do we write? No, you could do tangent squared equals something. Okay, what about if I take the square root of both sides? What do I get?
You get pi.
Do I get cosine equals sine? Exactly. I actually have plus or minus for both of them. So it's going to be plus or minus, guys, plus or minus. Right, when we take the square root, we need a plus or minus. So see what we did there? We took the square root and put plus or minus in both of them. So what is this saying? It's saying on your unit circle, the positive x value equals the positive y value. The negative x value equals the positive y value, right? So you could have all versions where your x and y are the same, and they could be any sign. Does that make sense? You can have a positive and a negative and a positive, positive, negative, negative. No. So where are these 4 locations? At all of the 45s, exactly. At like pi over 4. So Louis, you were saying pi over 4. Yep, you got it. Did you do that without the unit circle in front of you?
Yes.
All right.
Good job.
All right, so we get that. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Oh, just wait. We're going to have some where we have 8 solutions. You ready for it? Because I'm mean. I'm the worst. All right.
Don't kill me.
All right, so on this one, so I have 2 cosine of 2x minus 3 equals 0, or minus root 3 equals 0. So I'm going to add the root 3 over. I'm going to divide by the 2. So I have cosine of 2x equals root 3 over 2. Okay, I can't just divide by 2. That cosine of 2x is part of the angle. That 2x is like double an angle. Okay, I can't get rid of it. So what did I do last time? Do you guys remember? I doubled the interval. I doubled from 0 to 2 pi. I went from 0 to 4 pi. Yeah, but I did a w substitution. Exactly. So what we're going to do is we're going to say let w equal 2x. And we're going to find w's solutions on 0 to 4 pi. So we double the interval. So if we have 2x, we do 0 to 4 pi. If we have 3x, we do 0 to 6 pi. So what I'm solving is cosine of w equals root 3 over 2. But I'm finding all of the solutions on 2 rotations around the unit circle. Okay, so cosine of w is equal to root 3 over 2. Cosine equals root 3 over 2 in 2 locations, there and there. A little Pac-Man. So I get w equals pi over 6 and 11 pi over 6. But that's just one rotation. That's going from 0 to 2 pi. So now what about from 2 pi to 4 pi, the second rotation? Yeah, what I'm going to do is I'm going to add 2 pi to each of these answers. So what I'm going to get when I add 2 pi, I'm adding 12 over 6 pi.
So pi over 4.
Pi, no. Pi over 6 plus 12 pi over 6 gives me 13 pi over 6. And 11 pi over 6 plus 12 pi over 6 gives me 23 pi over 6, exactly. So those are what my w is equal to. So w is 2x. So if I want to solve for x, what I do is I divide all of them by 2. So I get x equals pi over 6 divided by 2 is going to be pi over 12. And then I'm going to have 11 pi over 12, 13 pi over 12, and 23 pi over 12. So the last thing I always do whenever I have one of these where I had to like double the interval and then have everything at the end, I just make sure I didn't go over 2 pi at the end. So 23 pi over 12, that's the biggest one I have. Is that less than 2 pi? Yeah, we're good. So we know that we did it correctly. All right, number 6. So we divide by a 4. And I take the square root of both sides. And I put a plus or minus. So I get sine of x equals plus or minus the square root of 1/4. So square root of 1 over square root of 4 is 1 over 2. So we're saying where is our y value equal to positive 1/2 and also negative 1/2. It's like a little bow tie.
So pi over 6.
Keep going. See if you can get them.
Yeah, I give up.
You got the first one. Pi over 6. 5 pi over 6.
7 pi over 6. 11 pi over 6.
Yeah, good. I know, Louis the pro.
I got the
It's ready for AP Calc. I'm just going to switch them right now. Go on AP Calc tomorrow. Yeah.
Enjoy that.
We don't have to because, okay, so Libby's asking a good question. She's saying, why don't we put a plus or minus here as well? Because really, technically, we should. But if you have, like if I had plus or minus x equals plus or minus 3, then that's saying positive x equals positive 3, positive x equals negative 3, negative x equals positive 3, and negative x equals negative 3. Right. So it's not really necessary to do both sides. We really just do one. So on that other one, I could have just done one side as well. All right, this one I have a sine squared and a sine. I can't just pull out a sine now, though, because I have that 1 over there. It's not going to be set equal to 0, right? So I have to get everything on one side. So I'm going to have 2 sine squared x plus sine of x minus 1 equals 0. And I factor using 2 sets of parentheses. So I'm going to factor into 2 sine of x and sine of x. And I know I need a 1 and a 1, and they need to be opposite signs. So if you think about it, when you look at your outer and inner terms, you have 2 sine of x and you have 1 sine of x. You want them to combine to be 1 sine of x. So you need a positive with the 2 sine of x swoop, I guess. So put a plus on the outside and a minus on the inside. I don't know what you're talking about. This is plus and this is minus.
Right, that would equal plus 1.
It has to be minus 1, so that should be the minus.
It has to equal positive sign, right? Okay, still, so if you FOIL that out, you get a negative 1, right? I'm pretty sure I'm right. So I set each one equal to 0. So I get sine of x equals 1/2, and I get sine of x equals negative 1. So when I find my solution, sine is equal to 1/2 at pi over 6 and 5 pi over 6. And then sine is equal to negative 1 at 3 pi over 2. Okay, so we have 3 solutions to that one. Okay, make sense?
Wait, what was it? How do you get this?
Pi over 6 and 5 pi over 6 were from sine of x equals 1/2. And then the 3 pi over 2 was sine of x equals negative 1. I just put them all together. All right, so next one, we have a little simplifying to do before we can factor. So we're going to distribute the 2. So 2 minus 2 sine squared x minus 5 sine of x plus 1 equals 0. So I have negative 2 sine squared x minus 5 sine of x plus 3 equals 0. And I don't like that I have a negative out front. Just like normal factoring, I hate when I have like negative x squared, like things like that. So I would divide by everything by a negative 1. So we get 2 sine squared x plus 5 sine of x minus 3 equals 0. Or you could have just added all of the things to the other side, right? So we factor. This is a tricky one to factor, so be really careful. So we have 2 sine of x and sine of x, starting it out, right? And we know we need 3 and 1, and they need to be opposite signs. So if you put the 3 and the 1 here, a lot of people will do that. So looking at my picture, do you guys see 3 and 1 there? You still have 5, but they would both have to be positive. Do you see how that's wrong? You need them to be positive and negative. So we cannot do that. So our 3 and 1 can't go there. It's going to have to go on the outside and the inside. So 3 on the outside, 1 on the inside. So now when I multiply, I get 6 sine of x and 1 sine of x. I need 5 sine of x. So I'm going to do a plus with the 3 and a minus with the 1. So when I set each piece equal to 0, I get 2 sine of x minus 1 equals 0. So sine of x equals 1/2. Then I have sine of x equals negative 3. So sine of x equals 1/2. That one's not bad. We just did that. That's going to be the pi over 6 and 5 pi over 6. What do you think with sine of x equals negative 3? What do you think we'd have to do? Just stop. Give up. No? Okay, let's think about it. What is the biggest value that you can have for a y value on your unit circle? What's the smallest value? Negative 1. Can you have a negative 3? No. A negative 3 on your unit circle is like, oh, this is 1 unit, and then we have 2, 3 units. It's like way down here. It's not even on the unit circle. It is not possible. So even if you try to do inverse sine or whatever using a calculator, it doesn't work. You can't have the sine of x equal negative 3. So your only answers are the pi over 6 and 5 pi over 6. Kind of a trick. So I think I did one on your homework where like It was like, I don't remember what it was. But maybe something like that. That also is no solution. Do you guys see why? Because subtract the sign from both sides and you just get root 3 equals 0. Right, that can't happen. So that's a no solution one. So sometimes you will get some weird ones that have no solution. All right, so number 9. So pull out a tangent of x. And then set each piece equal to 0. You cannot sit still at all, can you? Struggling. Throwing pens around. All right, so I get tangent of x equals 1 and tangent of x equals 0. All right, so tangent of x is equal to 0. So tangent, remember, is sine divided by cosine. Okay, so what we're saying is sine divided by cosine. The y value divided by the x value equals 0. Well, the only way that that's going to happen is if the sine is equal to 0. So you can imagine like multiplying the cosine over. It's gone, right? So we're really saying when is sine of x equal to 0? So we know that sine of x is equal to 0 here and here. So we're going to say at x equals 0 and pi. You could say 2 pi, but again, since I had on the interval 0 to 2 pi, but I had a parenthesis there, right, for the 2 pi, then we don't actually need to include it. It's not in the domain. Okay, and then tangent of x is equal to 1. Well, that's sine of x over cosine of x equals 1. So a lot of people on the last homework assignment came and asked me this outside of class. They were like, okay, well, I think it's going to be a quadrantal angle. I was impressed that they knew those words, meaning one of these 4. Because what do those 4 have? It's like 1, 0, 0, 1. They're the only ones that have like a 1 in them. But do you guys see how that's like not thinking like the right way with this? Exactly. It's the ones where it's like pi over 4. Because what we're saying is when are the sine and cosine values equal to each other? So when you divide them out, you get a 1. Okay, so if it helps, again, you can think of multiplying that cosine over. So what we're saying is when is sine of x equal to cosine of x? If it helps to do that, do that. So sine is equal to cosine in 2 locations, at pi over 4 and then 5 pi over 4. If it said sine of x equals negative cosine of x, it would still be 2 locations. It would be the 3 pi over 4 and 7 pi over 4, right, if they were opposite each other. All right, so we're going to have pi over 4 and 5 pi over 4. So we had 4 answers there. All right, almost done. 3 more. All right, so we have the double angle again. Do you guys want to try this one? I think you can do it. Try it. So try number 10. If you finish it, go ahead and try number 11. All right, so you should let w equal 2x. And since you have a 2x, right, we go on the interval 0 to 4 pi. We double our interval. So we're going to say sine of w is equal to root 3 over 2. So sine is equal to root 3 over 2 in 2 locations. So it should be at pi over 3 and 2 pi over 3. But we're going around the unit circle twice. Okay, so some people were having trouble with this earlier. If you add 2 pi, they were saying like, oh, in the last one you had a denominator of 12. Why do you have a denominator of 6? Or a denominator of 3 now or something. I don't remember. I had a denominator of 6, I think, before, and now I have 3. Well, it's because I have to do pi over 3 plus 6 pi over 3. Does that make sense? I need my denominators to be the same. So I'm adding 2 pi. I'm adding 6 pi over 3. So when I do that, I get 7 pi over 3. And then 2 pi over 3 plus 6 pi over 3 is 8 pi over 3. So that's all equal to 2x. So we divide everything through by 2. So we get 4 answers. The first one is pi over 6, right? Half of pi over 3. The next one is 2 pi over 6, which reduces to what? Pi over 3. 7 pi over 6. And the last one is 8 pi over 6, which reduces to? Exactly. So did anybody get all 4 of those? Perfect. Good. Some of you? All right, number 11. Kyle's very upset at me for putting number 11 on there. So mean. All right, why is it mean?
Because there's 3.
Yeah, it's 3x. We have to go from 0 to 6 pi. We do 3 rotations around the unit circle. All right, so we have cosine, so we're going to let w equal to 3x. So we're going to go from 0 to 6 pi. So I'm going to have cosine of w is equal to negative 1/2. So cosine is equal to negative 1/2. Oops, I don't know why I did it in the positive 1/2 location. So -1/2 here and here. So we're going to have W equals 2 pi over 3 and 4 pi over 3. So really what we're doing is we're finding coterminal angles. We're going to say, oh, it's the same location as 2 pi over 3, but it's just 2 pi past it. So if we're adding 2 pi, we're adding that 6 pi over 3 again. So the next one is going to be 8 pi over 3, and the next one's 10 pi over 3. So those are all the answers between 2 pi and 4 pi. That's the second rotation around. So we go one more time around. So we're going to add, you can add it again to the original, or now you can just add to the new ones. So add 6 pi over 3 to both of these. Right? So we're going to get 14 pi over 3 and 16 pi over 3. So that's what 3x is equal to. So if I want to get my answers, I divide everything through by 3. So your answers are going to be, you guys are like giving me death glares. It's fine, it's just a lot of writing. This is not a hard process. So much writing. You guys are experts at writing pi though now, aren't you?
Only if I can pick up pi. Even 3 over.
Yeah, there we go.
So what is pi?
I know you did not just ask me when Pi Day was. That's my favorite holiday. You should always remember it.
Well, I think it's 3.
Yeah.
I need 3.
Oh, I put a 3 instead of a 9. Man, Kyle got me. All right, next up. So number 12. That's probably when he said, when is Pi Day? I panicked. Oh, you should know that. All right, so add the 3 over. Divide by 4. I didn't. I said, all right. Square root, plus or minus. Cosine of 2x is equal to plus or minus root 3 over 4. So this is when I had a lot of people in the last homework come to me and say, this isn't a unit circle one, like in things like this. So think of it as square root of 3 over square root of 4, which is going to be root 3 over 2. It is a unit circle one. You just have to like go a little bit further. Especially a lot of people ask that about square root of 1/2. Because it's square root of 1 over square root of 2, which is 1 over root 2. And then it really doesn't look like a unit circle value. But remember how you have to multiply by root 2 over 2. Root 2 over root 2. So your answer is root 2 divided by 2. Right, that is a unit circle value. So a lot of people ask me about that one. All right, so on this one we're going to say let w equal 2x. And we're going on the interval 0 to 4 pi. So we have cosine of w equals plus or minus root 3 over 2. Ooh, it's going to be a lot of answers. You ready for it? Because it's cosine equals plus or minus, so there's already 4 answers for one rotation. So there's 8 answers total. All right, so we're going to have plus or minus root 3 over 2. So those 4 places. So we're going to have w is equal to pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. That is one rotation. And we're going to find the coterminal angle, so we're going to add 2 pi to each of those. So we're doing one more rotation for each one. So if I add 2 pi, what I'm adding is 12 pi over 6. That's the same as 2 pi to each of those. So I'm going to get 13 pi over 6, 17 pi over 6, 19 pi over 6, and 23 pi over 6. We're not done. Do you think we're done? That's what 2x is equal to. So x is equal to pi over 12, 5 pi over 12. They're all easy because they're all over 12. 7 pi over 12, 11 pi over 12, 13 pi over 12, 17 pi over 12, 19 pi over 12, and 23 pi over 12. Ding, ding, ding. All done. All right, I told you some of them are long, but it wasn't hard, right? You guys know how to do it. It just takes a little bit to write them all down.